Hello, everyone. It's Mr. Kissinger at the Citizenship Academy in Syracuse, New York. This is 5th grade math, module 5, lesson 1. We're starting a brand new module, and we're going to actually be doing a brand new concept here today. We're going to be exploring volume by building with and counting unit cubes. So I'll show you kind of what we're talking about here. We have these diagrams here. It says the following solids are made up of 1 centimeter cubes. Find the total volume of each figure and write it in the chart below. So if we look at letter A, we have 1, 2 cubes here. These are three-dimensional cubes, three-dimensional shapes. Right here we have 1, and this is the side, and then this is the top of that cube. And then here we have 2, and again, there's the top of that cube, and then this is the right side of the cube. Just so everybody sees what we're talking about here. And what we're going to do is, it says these are made up of 1 centimeter cubes. So every direction, this is 1 centimeter this way. So it's 1 centimeter by 1 centimeter. And then this way, too, back is also 1 centimeter. And we call that 1 cubic centimeter. So this shape right here will be 2 cubic centimeters. And just like with, if we were going to do square centimeters, we put a little 2 there. With cubic centimeters, we're going to put a 3 because it's 1 centimeter in 3 directions or 3 dimensions. So letter A down here in our table, our volume will be 2 cubic centimeters. And in my explanation, I'm going to say there are 2 cubes with a volume of 1 cubic centimeter each. So let's look at letter B. We'll count. We have 1, 2, 3, 4 cubes. And each one is a cubic centimeter. So we know that our volume will be 4 cubic centimeters. So 4 centimeters cubed. Letter C. Now we have 1, 2, 3, 4, 5, 6. 6 of those cubes stacked on top of each other. It's kind of like a building. It would have 2 floors. We have 3 on this floor and then 3 sitting above on top of them. This one is 6 cubic centimeters. So letter D is a little bit different. So this one has something kind of strange about it. So let's count our cubes. I see 1, 2, 3, 4, but I also see 1 back here. This is going to be 5. And we can't see the 6th one, but in a diagram like this, if it's pictured this way, and it looks like there is, this one would have to be sitting on top of a cube back here, or else it'd be floating on thin air, we're going to assume that there's a 6th cube back here. Because if there wasn't, the diagram would show us that. So this actually has 6 cubic centimeters. It looks kind of like a staircase here. But we have 4 on our first floor of our building, if you will, here. And we have 2 cubes on our second floor. So this is actually 6 cubic centimeters as well, just arranged in a different way. We have the same thing with this kind of block here of letter E. Yes, we have 1, 2, 3, 4, 5, 6. But we have 2 layers to this. There's a whole other layer behind it. So there's, 7, 8, 9. And then we have this one, which is 10. And then right behind 5 here will be 11. And then behind 4 in the back there will be 12. So we have 12 cubic centimeters there. We have 6 here in this layer, and then we have a whole layer behind it there of more cubes. So that'll be one big block. And that's going to give us 12 cubic centimeters. Finally, we have this one here. We have, this time we'll look at it a little bit differently. We'll look at kind of like the second floor of our building here. If we have 1, 2, 3, 4, 5, 6, 7, 8. So the top floor here has 8 cubic centimeters, and there's a whole floor below it too in that block. And there's another 8 down there. So if we have top floor, we have 8, and on the bottom floor, we have 8. That gives us 16 cubic centimeters. And our explanation is going to be about the same for every one of them. We have cubic centimeter blocks, and we have different numbers of them. So I'm kind of just going to draw an arrow down here. Our explanation is going to be fairly similar for the rest of them. So this one, this will get a little bit tricky here. It says, draw a figure with the given volume on the dot paper. So we're going to use this triangular dot paper to draw ourselves some cubes. The first one we have to do is we have to draw 3 cubic units. So I'm going to draw, here's the side of a cube there. And I guess I'll draw it down like this. We could do it a number of different ways. I think this makes the most sense. Then this. Oh, I made 6. It did 3. So we're just going to make 3 just like that. So we have 3 cubic units here. As you see, we have 1 cube here. So this one here, so this would be the bottom of our cube right there that I'm coloring in. And then this would be the right side of the cube. This would be the right side of the second cube. This would be the right side of the third cube. And we can't see the top. So we have 3 cubic centimeters there. Or 3 cubic units. We don't know the exact measurement there. So if we want to draw 6 cubic units, I'm going to start the same place here. And I'm going to start with 3 cubic centimeters and then draw 3 more. 1, 2, 3. 2, 3. Yeah. 3. All right, so here is our 3 cubic centimeters. And then I'm just going to add another 3. So I'm just going to add another layer. Go here, down 3. And now I have 6 cubic centimeters. So here's the bottom of our cubes. And here's the right side. And then there's the top of them right there. So we just have the same thing, but an extra layer. Now this third one here is asking us to draw 12 cubic units. So I'm going to start by drawing 6. 3. I'll start by drawing the face here. I did on the other one. All right, so there's my 6 cubic units. And then I'm just going to add another layer. So I'm going to make 6 more here. All right, now I kind of have a block here. Like here's the bottom of the block. And then here's the right side. And then there's the top in white again. So there's 3 here. Here's 6. And here's 12. Now, question 3 says, John built and drew a structure that has a volume of 5 cubic centimeters. His brother tells him that he made a mistake and only drew 4 cubes. Help John explain to his brother why the drawing is accurate. So what John's little brother is seeing is he's seeing that we have 1, 2, 3, and over here 4 cubes. So he's only seeing 4. And this is sort of like on the previous page when we had this one here. We assume that this number 1 block here isn't just sitting on top of thin air. We assume that there's a block back there, and that diagram would show us if there was not a block there. So we have to assume that on top, below this 1 block here, there's a 4th cube on this bottom floor of this building, and then there's only 1 on the top floor. So there's 1, 2, 3, 4 that one's sitting on top of, and then that number 1 block as well. So there's really 5 blocks there. So there are 5 cubes, but 1 is hidden behind, or I guess I should say underneath, not behind. Since I labeled this, I'm just going to call this block number 1. All right, and then finally, we're going to do this number 4 here. It says, draw another figure that represents a structure with a volume of 5 cubic centimeters. So I'm going to do, we can do it a lot of different ways. But I think I'll do it this way. I'm just going to do a straight line. 1, 2, 3, 4, 5. That. Goes the other way. 1, 2, 3, 4, 5. Stop right there. Draw myself a line. To connect all these dots. And there it is. We have 5 cubic centimeters. There's the bottom of my figure there. And there's the right side. And the top there is in white, so we can kind of see that 3-dimensional object. And that's where we're going to stop for today. Thank you guys so much for tuning in, and I look forward to seeing you next time.